All right, thanks for having me. Can you guys hear me? Do I need the microphone? I'd prefer not to. Good. All right. Well, awesome. Well, thanks for having me again, Adam, Luis, Raphael. It's great to be here. So we're going to talk about untangling data in a web of microservices. So I'm pretty informal, so ask questions. Who here knows what microservices are? Spending time working in microservices. We're going to talk a little bit about the data journey that folks in reporting and analytics can sometimes deal with. So quickly, I'm Benjamen Pyle. So I'm a 25-year veteran in technology. I'm currently CEO and co-founder at a company called Pyle Cloud Technologies. We're a serverless consulting and AWS consulting firm specialized in architecture, training, cost optimization. I'm generally somebody that likes things compiled versus interpreted. I had a good conversation about Rust a little bit earlier, so if you saw last month, you know how much I like Rust. A few people out there know about it. I'm an AWS community builder, which is a little bit different than our user group here, but it's a AWS sponsored program, and my focus is, like I said, in the serverless space. And I've been everything from an engineer, an architect, a CTO, so I've probably been in a lot of the seats that you guys are sitting in right now. So we're going to talk through a few pieces. Oop, kind of cut off there. First off, I want to acknowledge one thing. Reporting is really hard. Anybody agree with that statement, right? Reporting is always the thing that happens after engineering ships a product. And then it often requires you to go back up the stack to figure out, why didn't you collect this data that I need to deal with my problem, right? Reporting people, I feel sorry for reporting people just as much as DevOps in a lot of ways, right? Reporting people have it pretty hard. Microservice makes it harder. We'll look at why that's the case. And then I've got 3 proven ways to untangle data. It's not the only 3 ways you can untangle data, and it's going to have some caveats to it, but we'll talk through what those means. And then I'll kind of expose you to a few next steps along the pattern. So just so we're clear, everything will be AWS focused, highly serverless, and ways that you can untangle your data. So first off, why is it hard, right? So systems are built around transactions, like I just mentioned, usually optimized around the API. It's optimized around the application. It's not always thought about reporting. How many times in a project do you get asked a question, why didn't you capture that data? The engineer says, well, the product owner didn't ask me to capture that data, which then turns into a whole cycle to go back and recollect it. So traditionally, data is stored to support reads and writes. Again, how often do you write data in a really wide format to make a SQL query perform better for you after the fact? Generally doesn't happen that way. Generally, product people are more focused on throughput, what the user experience is, how can we handle failure, how can we deal with problems. They generally don't go, well, did you make sure you stored that data in a way that I could summarize it 6 weeks from now? Reporting can be an afterthought. Like I just mentioned, it is not always at the forefront of what a product person, a developer, or even sometimes a customer is thinking about. And so you end up going back up the stack to pull data in and out. Users require these reports and analytics. Again, they're not always the same thing. So if you're working in, let's say, Java, and you're building an API in Java and Spring Boot, that's not the same tool that you're going to use to build a pixel-perfect report. You're going to use Jasper, SQL reporting services. You're going to use QuickSight in Amazon, right? You're going to use Glue. All these tools that don't sound like Java that you're going to have to take advantage of. Everybody kind of agree with this premise? So what does it look like in the monolith? So everybody understands microservices. We'll talk a little bit more about that in a second. In the monolith, it's pretty simple, right? The monolith assumes that the application all exists in one container, one run space. You have a fleet of EC2 instances that are running the same copy of that executable. They talk to one database, right? Maybe a really big database. Could be 64 CPUs and hundreds of gigs of memory, but it's one database. And so when it's time to do reporting, what happens is one of 2 things. You build the reports right off on top of the SQL or the Postgres or whatever database. You write queries in the same place that the developers are working on when they build their transactions. And if you want something more custom or analyzed, who's used to having to wait 24 hours for the business intelligence models to run so that I have access to that information tomorrow, right? Pretty common scenario. And then we'll pipe things over into usually Redshift, and then again, then you can pick up and you can use QuickSight, you can use Jasper, you can use all these other tools. So in the monolith, a lot of product people will typically go, well, I just want you to give me the data the way I'm used to seeing it, right? Because this is what most people's experience is. But as we shift into microservices, right, microservices come with this notion that things are isolated, things are distributed, things are protected from other things. So in this world here, we've got different slices of that same monolith where data is only shared over APIs and events. So if I'm in that top AWS Lambda talking to DynamoDB, and I'm down there in the bottom as an engineer trying to talk to that database, I can only go through APIs. I've naturally just created data silos. Who here knows what a data silo is? It's a place where only certain people can get to information. What do business intelligence people spend a lot of time dealing with? Data silos. Microservices naturally creates data silos. And most people don't think about this ahead of time because, again, you go back to the beginning when I was talking about they're focused on transactions, reads, writes, performance, availability, all of those things. So when you're in a microservice environment, do you think product just says, well, guess what? We don't need analytics. We don't need reports. They still have the same questions, but now we've created challenges for them to accomplish that because of the fact that we've created these data silos. So let's jump into what those 3 patterns are going to look like in order to take what is a very modern approach and how we can go back to reporting on information out of it. Any questions before I move on? Everybody agree with this premise? Anybody seen this already? Seen this movie? All right, so 3 patterns, and these are not like, these are my names, so this is what I generally call them. So there's a replicate to read pattern, there's a split for read and speed, and there's an eventually readable pattern. We're going to get into what each one of these are, but these are the 3 ways that I like to look at AWS microservice-based systems using RDS, using DynamoDB, and how can I then take that to a place that my business intelligence developers can now code on something that they can work with. The first up is replicate to read. So if we take this scenario and say that we've got, do I have a pointer? I thought I did. Well, if we've got 3 services, right? Users, orders, and items. It's probably a pretty reasonable request that I'm going to want to see all the items in that order, right? Seems pretty reasonable. But if I'm sitting there with 3 different microservices, how am I going to be able to accomplish that? Well, the simplest of these patterns is that you just basically join up off the RDS database. It's kind of like the monolith, right? I might have 3 databases that I want to join data back up, and I can simply just query right off on top of it. I get speed out of that, right? Because now I don't have to worry about transformation. I can just write my queries, I can join the data, I can blend the data. I get simplicity because as a data and analytics developer, all I really need is a connection string, right? I just connect into the databases and off I go. And this will generally work, and a lot of times, depending upon how much size you have, this may be perfectly fine. And I think a lot of times we struggle with the solution needs to be elegant, when really the solution just needs to be functional and meet my needs, right? And if my needs are met by this is fantastic. The downside to this, though, if you can see it is, it's not optimized. So let's say that I need to pre-calculate some piece of information. Guess what? These are transactional tables. Transactional tables aren't traditionally pre-calculated, right? Just the way it's going to be. If I need another set of data that's stored in a slightly different way, I'm not going to have that at my disposal. Data blending. So if you think about, I'm just kind of struggling with the directions. If you think about the analytics that are coming off of this, how am I going to get those 3 sources brought back together? So if I'm using Amazon's QuickSight, which is fantastic, by the way, you can simply bring those together in a nice query engine that then you can then cache, you can report on, you can optimize, you can even make your own models on top of it. QuickSight would be a fantastic use case right here because I get really, really, really powerful data blending and I get the ability to really reshape that data. So if this is you and you want to look at QuickSight, great place for this. But let's say you're not using QuickSight, you're blending it in Jasper, or you're blending it in SQL reporting services, right? So you're going to have some pain around how that's actually going to come together, and you're going to put a lot of burden on your reporting team. But again, if this is your problem and you've got RDS, it's a great solution. The other thing too that you might run into, which this one can deal with, who knows that you only get so many connections in RDS based on how big of instance you have. I may only get 100 connections. Let's say that my microservices collect or require 20 connections per container. I can get 5 instances of that container. Guess what I can't do now? I can't report, right? Because reporting is going to need connections. So one thing that's really nice about this is RDS has built-in read replicas that you can take advantage of, and then you can then further extend, because you don't need writes as a reporting developer. You just need to be able to read. Moving on from this one, let's say that you've got a mix of NoSQL in here. This is pretty simple if you're purely SQL. There's nothing wrong with being purely SQL. The world is built on SQL. But if you do like a NoSQL flavor, if you haven't learned DynamoDB, totally encourage you to go look into it. It's fantastic. You don't deal with connection management. You do other problems, but not connection management. But let's say you've got an environment where you've got this mixture of speed and read, because now I have DynamoDB. Well, DynamoDB is a NoSQL key value data store. Guess what it's not good for, like really, really bad for? Reporting. It's great for key value access patterns. You can do a little bit of searching depending upon how you design it, but you can't write complex joins and complex filters without paying a significant penalty on cost and performance. But what DynamoDB does support is something called DynamoDB streams, or being able to take DynamoDB's events and put them into Kinesis. Everybody know what Kinesis is? It's a giant stream bus that operates a lot like Kafka does, that you can put events and then you can replay and read events at your leisure in order to do something with those. Supports multiple consumers and supports enhanced fan-outs and a whole bunch of other pieces. So if I was going to have this approach, what I would probably do is I would go to Redshift. Who here is aware of Redshift? Redshift's a big column or data store built for enterprise data analytics. Also supports SQL. Also supports a really clean data API. It's a fantastic choice. But I need to get that data transformed out of DynamoDB. So what I'm going to do is I'm going to go to a stream, and I'm going to go to step functions, and I'm going to get that data straight over into Redshift. And so now I've got SQL for SQL, right? I can keep my data where I have it in my users and orders table. And now I've got items in Redshift. So now I've got 3 databases that I can connect my tool up with, which again, QuickSight would be a great spot to use, or I could also come back and continue to use my Jasper or my SSRS or whatever it is that I was using. But this one's kind of a blend, so you still get a balanced approach, and that I'm using the same SQL tooling. I'm already getting good value out of my read replicas, so now I can enhance that a little bit by my bringing in of DynamoDB. And I've got a really nice blend of these two sources to provide me some analytics and reporting out of. The downside is I'm still dealing with connection management, right? I'm still dealing with the fact that I got to figure out what I'm going to do with how many connections I can access this, that, or the other. I've got additional overload in Amazon Redshift now. My data blending still happens in my reporting tool. And I'm low on extensibility. Right? Like, this is pretty purpose-built for reporting. If I wanted to do something else with this, like prepare it for more advanced analytics, or put like SageMaker or some kind of machine learning workflow on top of it, this would struggle, right? You'd have a hard time getting to that point right here. So this one is one of those ones where if your product team's like, I need the data now, and I want it the way I want it, you can fit your pattern into this. You can get there with this direction. Does this make sense? It's kind of a blend. Like I said, you're going to use your current data in place, and then if you've got more of these DynamoDBs. So DynamoDB is going to support 1 stream per table. If you've got 10 tables, you've got 10 streams. So you are taking on a little bit of additional overhead. So moving into the last pattern, the one that I like the most is, this is the eventually readable pattern. And the reason that I like the eventually readable pattern is this. I've started to coalesce everything around one data model, right? So if you take a look, we've got our users, we've got our orders, and we have our items table, our items service. If I want to get all of that data back together, I want it unified. I want it in one place. right? I want to be able to look at it with one view. I also want to start to separate out the fact that my engineering teams don't have to worry about the reporting team touching their data, right? Because I'm not touching the read replicas. I've consolidated around this thing. Everybody's heard the term data lake, right? So this centralized repository for where unified data can go. And then I'm also making use of the fact that from the data lake, I can get data into Amazon's Redshift through using Kinesis. What I really like about this is the flexibility of it. Once I'm in data lake, guess what I can do? I can do additional machine learning things on top of it. I can use it as a mechanism to send pub/sub data out. I can curate it with lake formation so that certain users can access certain resources. Right? I can do a lot of things in a data lake that I can't do when I'm just looking at transactional tables or I'm looking at Redshift. And in this specific use case, I can still get my Redshift use case out of it, but I could also get a whole bunch of other things in place. What I'm giving up here, though, which is super important, is I'm giving up speed, right? And speed's relative. Like as a Rust developer, like we talked last month, 10 milliseconds makes a lot of sense. To a C# developer, 250 milliseconds might not make same difference. Depends on what you're going after. In the first model, I can read exactly where things are. The second model, I take a little bit of latency to get it into Redshift. That latency is going to be less than, I don't know, it's going to be less than a handful of seconds at most. In this model, I could take up to a minute or two. Is that worthwhile to your business use case? And the reason it might take up to a minute or two is that's what's missing, or it's hard to see. You guys see the little green box in the middle that says AWS's data migration service? Data migration service is typically thought of as a service that gets your data into the cloud. A little known factor, maybe it's not little known, but it's little known to everybody I talk to. You can also use it to naturally and automatically move data from RDS to somewhere else. So in this case, I'm probably moving it to S3. DMS has a 30 to 60 second lag, generally, for it to trigger data to go through. So anytime you're using DMS, it's always good just to factor in that little bit of lag. However, back to the Lambdas, we're getting real-time changes coming out of DynamoDB. So again, speed is relative. If a couple of minutes is not too slow, you gain a ton of flexibility for a little bit more latency. Any questions on this?
Just one comment.
Yes.
So what we are seeing is this data lake is like the central hub across organizations, different lines of business.
Mm-hmm.
That's something that, unlike these different databases that could be per application or
Mm-hmm.
could be per microservice, really organizations should look at this data lake as their central silo. Right?
Yes.
And S3, you mentioned S3. S3 is a great example of a data lake,
Mm-hmm.
which is scalable.
It is.
Extremely scalable.
Yep. AWS's Health Lake is another one, also built on top of S3. It's a really good point because it's true. Unification of data, going back to the beginning, we've created data silos by using microservices. Now we're able to bring it back together by getting in a unified spot. Any more questions on this one? Getting into that view and analytics, again, it doesn't really matter what you're using. QuickSight would be fantastic. QuickSight could connect directly to S3. QuickSight could connect to Redshift. Again, you've got a lot of flexions and options. So next steps, I skipped over all these. Next steps, what I think would make the most sense if somebody was going down this journey, right, and really looking down this path. Governance is something that once you start to move toward a data lake, super important, right? AWS's Glue Catalog, Lake Formation. These are tools that can help you organize, make sense of, protect, isolate your data when it's in that place. Data movement, one thing I love so much about AWS, I have a lot of options, right? In my diagrams, I had step functions. You don't have to use step functions. You might be able to get it all done with Firehose. Firehose supports transformations. You could get that there. Kinesis data streams, Event Bridge, those are good ways to move data. They give you a lot of customization that you get for free coming out of the box. Transform and compute. Lambda is a really natural winner in this space, right? It's event-driven. It's compute on demand. It meets you where you are in terms of tooling. Want to use Python, use Python. Want to write Java, write Java. You can really deploy anything you want in there. Step functions is the same way. I found with step functions, Raphael did a great talk last month on step functions, that sometimes you don't even need to write code to use step functions, which is even the best part. Codeless code is the best code. And then you've got EMR, which is not something I'm 100% familiar using a bunch, but it is around like MapReduce and Hadoop and the old school kind of approaches, but it's another service that you have at your disposal. And then looking into querying and viewing, I mentioned QuickSight probably 10 times. QuickSight's a fantastic service. It's got a built-in data caching and virtualization layer in Spice. You pay on demand. You can build data sets. You can share data sets. You can isolate data sets. It's a fantastic tool. And then anything with S3 Athena, because you're going to be writing queries. You have a question? Look like you're going to ask me. OK, cool. These will be where I would start. Next steps. Take a look at these guys. And that's it for me. So references for this, there's an article that's out that's around reporting with serverless. Makes a ton of sense to get in front of. The Amazon data endpoint will show you all the different data capabilities that are out there. And then looking at data lake. If you're exploring data lake, it's a huge concept. That endpoint's a really good place to get started. So thank you very much for your time, and I appreciate it.